All right, so what we're going to do is continue with 4-6 today. So 4-6, we're going to be factoring still, but we're going to be specifically factoring quadratics. What's a quadratic? Somebody tell me, please. Sure.
Can you tell the quadratic polynomial?
What's up? What's a quadratic? What is a quadratic in general? Not what is a quadratic form? What is a quadratic? Yeah, very good. A polynomial with degree 2. Let's say that. A quadratic is simply a polynomial that is second degree, meaning it's squared. If it's x cubed, it's not a quadratic anymore. That's a cubic. Okay, the word quadratic is very misleading. I disagree with it completely if you ask me. Because when you think quad, what do you think? 4. When really it's 2. Okay? For some reason, mathematicians decided to call x squared quadratic, x cubed cubic, x to the 4th they called quartic. And then x to the 5th is quintic, Q-U-I-N, 5. But nobody says anything beyond quadratic and cubic.
Sextic.
Probably. And 7 is probably septic, but nobody really says that. Octic? Yeah, probably. You go on and on, right? Now, the idea is this. Quadratic and cubic are the ones that we're going to really focus on as specific types of functions, and then just general polynomials after that. But quadratic, remember, has a degree of 2. Now, a quadratic can be written in either form. It can be written in what's called standard form, which you see here, or it can be written in another type of form, which we can call either root form or factored form. Okay, either way is fine. But today our goal is to figure out how we can transform from the standard form into the factored form. And obviously I know some of you have done part of this already, but there are tough problems that maybe you haven't done yet, or methods that are new that might help you, especially when it comes to your SAT for factoring. Okay, there is some factoring on the SAT. Now, first, before you factor anything, remember always look for a GCF. If there's a GCF in the problem, immediately factor out the GCF. After that, you're going to think of 2 possible cases. Okay, 2 possible cases. And you don't have to do these examples. I just want you to see what they are. First, the first possible case is when a is equal to 1. Well, what do I mean by that? Take a look at x squared. What's in front of the x squared term? Joe? A 1. That's the a value. Whereas down here, when a is not equal to 1, see there's like a 15 in front of the x squared? So those are the 2 cases. If it's the first case, it's actually quite simple to factor. If it's the second case, we're going to use AC method. Okay, and I'll explain what that is. It's a type of grouping. If you remember, we did grouping with factor. So in the upper case, we have to think about 2 numbers that add up to give us b. So we want 2 numbers that add up to b and multiply to give us c. So add up to b and multiply to give us c. Ian, give me those numbers for this one. 2 and 3. Very good. Does everybody see that?
You don't come to x, the variable, right? Just the coefficient.
Say again?
You don't have to use the variable, like I just moved 3x plus 2x, right?
I'm sorry.
B is 5x, right? So I just consider this 5.
Yes, so you're just thinking of 5, because you're looking at the sum of b, not bx. Who's b? Yeah. So no variable there. So for this problem, we know already that we're going to have x plus 3 and x plus 2. Okay, and up here, you know what? Change this, please. Make this x plus x1, x plus x2. It really doesn't matter. Different books you can see different ways. But just to make it consistent with what we had for our first answer there. But again, it can be minus also, right? We all know it can be plus or minus depending on the numbers.
Now, what is something with a equals 1, a is not equal to 1? How do you know that?
Based on the problem. You'll be given a problem and you'll see. If a is 1, if there's a 1 in front of you, you just do this.
Okay.
If not, then we have to learn what AC method is.
All right.
Okay? Let's go to the next slide. So what we're going to do is we're going to start with an example.
Is AC method one where you find the number, like you multiply the a
A
and
times
the
C.
c, and then you find the number,
And you
and
bring
then you
the
plug it in
term.
and factor it out, and then you have like the 2 things in front. Okay.
So let's look at the first one, factor the quadratic expression. What numbers add up to 3 and I know a lot of you know right away, but let's make believe we didn't know. Okay? Here's how you do these problems. If you ever don't know off the top of your head, think of all the factors of negative 28. Give me a list of them. Give me one example.
1 to negative 28.
Okay? So by default, I could have negative 1 and 28 also. Good. Another. Joy? 4 and 7. And I'm going to say negative 7, right? Or positive 7 like that. What about 2? 2 and 14, right? Agreed? Is that everything? 5 doesn't work, 6 doesn't work, nothing else works. Which of these combinations now adds up to give you 3? This adds up to negative 27. This adds up to 27. Notice the opposite signs here. Ian, which one is it?
Negative 4 and 7.
Yeah. This is the only one that adds up to give you positive 3. There will always only be one answer. There will never be more than one answer. Is that clear? If you can factor, it can only factor one way. Now, there are some instances where it can't factor, and none of the possible solutions will work. Like, for example, what if this had not been a 3? What if that had been a 4 in the middle? Do any of these add up to give you 4? So then it would be not factorable, or we call that prime. In your textbook, the textbook said, state if it is prime or not. Okay, that's what prime means, you can't factor, but we can. So these are the factors. So I simply go ahead and I list x minus 4 and x plus 7. Is that clear? Again, I choose these two down here. The minus 4 is one of them, and the plus 7 is the other. Any questions on this? No? We're good? Okay, cool. Let's take a look at the second one now. The second one, clearly, A is not 1 anymore. Does everybody see that? What is the value of A, everybody? What is it? 3. Everybody, right? Thank you. 3. Very good. A is 3 here. So right away, we know we cannot use that simple factoring technique. Now, a lot of you will notice that, sure, your answer is going to look something like this. Right? Everybody see that kind of? Because the 3w times the w is the only thing that's going to give you the 3w squared. So you know that part of your answer is going like that. But the question is, I can have so many possible options for you. It could be 1 and 8. It could be 8 and 1. It could be 2 and 4. It could be 4 and 2. I don't want to sit here and do trial and error. Because there's going to be problems when I have a number like 24 here instead of 8. And then 24 has so many factors. 1 and 24, 2 and 12, 3 and 8, 6 and 4. You want to try 30 or 8 different combinations, I guess that would be, and see which one works. So what we want to do really is develop a technique that allows us to always get the answer. And it's called the AC method. And that's what I think I called it before. I don't know what's actually called. Sure. So tell me what AC is.
So A is 3.
Good. And C is?
C is negative B.
So AC is?
Negative 34B.
Okay. What is B?
B is negative 10.
Now, Nick, what are we doing at this point? Instead of like, remember last problem, we looked for numbers that multiply to give us this and add it up to this?
So instead of doing that, we get the AC, which is negative 24, and you're trying to find out what multiplies to the AC and adds up to the B.
Good. Let me pause you because you're right, and I want to make sure it's clear. In the last example, we looked to see what numbers multiplied to give us C and added up to B. But really now, as Nick said, now we look for numbers, what two numbers multiply to give us this number and add up together to give us this number here. Okay? So we have to think, what are the factors of negative 24 that add up to negative 10? And there's a lot of them. So we could start listing them, but it might be easier to start doing in your head. Okay, so in my head right now, here's what I'm thinking, just so you guys know. This is what I'm picturing in my head. I'm picturing 1 and 24, and I see what's the difference between those numbers? 23, right? One of them's going to be positive, one of them's going to be negative. But the difference is 23, and that's not 10, so it's not going to help. The next factor is 2 and 12. What's the difference between those? 10. So those might be my answer, right? And that's how I want to think about this process. So now give one of them a negative and one of them a positive.
So negative 2 and 12.
need a
Oh,
negative 10.
sorry, negative 12.
Yeah. So we want a negative 10, so this needs to be a negative 12. So when we sum these two values together, we get negative 10. If you try any other combination, 3 and 8, what's the difference between 3 and 8? 5. Not going to work. What about 4 and 6? What's the difference? 2. That doesn't help us. We want to find a positive and a negative number whose difference is 10. Okay, or when summed together, we get 10. Or in this case, negative 10. You remember the next step?
So since you get 2 and negative 12, you have to put it inside there.
No. Inside where? Maybe.
Oh, you know what? Okay, so you get 3w squared.
Okay.
And then you do plus 2w minus 12w.
Good.
And then minus 8. So what you should
Slow down, slow down. So what did you do in words?
I put the AC in the B. I just plugged it back into the original equation but got rid of the actual.
Okay, so what Nick did is he took this negative 10w and he used the substitution method and he substituted in this expression right here. Somebody tell me why that is mathematically sound, why you are allowed to do that. Right. I mean, that's a process, but that's not the answer. What? Good. Okay, good. You're not factoring, right? Factoring is when you break something up into its factors, then multiply. You're taking this and breaking it up into sums. So what you're really doing is thinking about it this way. If you were to simplify in the middle, wouldn't you get negative 10 here? Isn't that what the original was? So this is mathematically legal or sound. Okay? Continue.
Can I switch those?
No, you can't. Sorry. You could. You could always switch the order of them, but I'm going to say no. You get the same answer. It's easier the other way, but I want you to do the tough way.
Alright. So you group them
Okay, so we group. So look at the first two. What's the GCF?
W.
W.
So
What are you left with?
3w plus 2.
Okay.
And you get 4.
Well, what do I mean over here? What's got to be in that parentheses?
Negative 4.
Good. So I wanted to go over that. You need a 3w plus 2 here. You have to get that for this to work, okay? So in order to get 3w plus 2, you don't just factor out a 4. A lot of people factor out a 4 out of here. You factor out negative 4. It's very important to put the negative sign there. Again, and go back and think about it. Now you have negative 4 times 3 is negative 12. Negative 4 times 2 is negative 8. So this works if you work upward, okay, if you check your answer. And notice, as we said from last class, the grouping method works when the factors are the same here. Because now I can think of those as a GCF, and I can take my w minus 4 out, take out the w and the minus 4 out, and you're left with just 3w plus 2. And as we suspected at the start of this problem, as we suspected in the beginning, we had something with a 3w and something with just a w. Again, why does that make sense? Because 3w times w gave us this 3w squared right here in the beginning of the problem. So AC method will always work if the problem is factorable. If you can't factor it, if it's prime, then you're going to get to a spot here where these two things won't match up. Okay? Or you won't be able to find numbers that work to add up to this and multiply to give you this. Okay? And then there would be no factored solution. Yeah. We'll learn about the quadratic formula where we can find the solution to the equation or the polynomial in other means. And we're also going to use our calculators with this and write programs on the calculator. So make sure that in the next few days you have that calculator on. I know you do every day, but just to make sure, because we're going to be writing a program and we're going to actually be doing some coding on it. Okay? Any question on this before we go on? We're good so far? Now, Nick's question before we go on, was can we switch the order of the middle two terms? Sure you could. You could have written minus 12w plus 2w instead. And then over here, your GCF would have been a 2. This would have become 2w minus 4. Over here, your GCF would have been a 3w, and it would have been a w minus 4. And you get the same answer. Everybody see the w minus 4 repeating itself? There's the w minus 4. 3w plus 2. 3w plus 2. So again, this would would line up with this now, this way we factored, and these two, the simplifier would come out to be this one. So it does not matter about the middle two terms. That's why I said no. That's the reason I wanted to show you that. Yeah. All right. Now, we talked about square of a sum real quick, and I said you're not going to really need it to memorize it much, and you really don't. But it's a good trick to know when you're factoring. It does help a little bit. So let's look at the first example. What numbers multiply to give me 16 and add up to 8? Multiply the 16 and add up to 8. 4 and 4. So this becomes x plus 4, x plus 4. By the way, anybody notice the orientation is good on the board? Nobody noticed, right?
Why?
They fixed the board.
You didn't fix the
I don't know. They what?
You didn't fix the sound.
Not the sound yet? Yeah, maybe they're working on this. But they fixed the board right before break.
Sure.
I mean, look at this. It's amazing, isn't it? Watch. I can actually scroll up and down.
Did you not even say it?
That's true. Sorry, Hannah. We don't need you anymore. Look, they come out for
Oh.
kidding.
Smart.
Obviously.
Yeah,
Okay. So anyway, how would I write this? How would I write this? I see it's x plus 4 twice. What's a simpler way to write that? Good. Alright, so look. All you're seeing here is the following. If you have something in this form, okay, if you have some quantity squared here, like 16, you take the square root, you get 4. Well, that's half of 8, isn't it? Whenever that happens, that's going to be your solution automatically. I really don't want you to memorize it, but there are some times you can pick up on patterns that help. How about the second one? What would the second one become?
Would be x plus 5.
Well, u, but,
Oh, yeah.
right? And it's a 5 for sure, but is it a plus?
No. Plus or minus, right?
So let's say minus 5 both times. How come it's minus both times? Yeah, you add them, you still get a negative 10, right? And when you multiply them, you get positive 25 at the end here. So this could just be written as u minus 5 squared. Remember, guys, that's why there's a plus or minus here and a plus or minus here. Okay? It could be positive or negative, Joe. Sure. The middle one. The middle one. Based on the pattern that we're working with here, what might you suspect it is?
I see that it is w minus 2.5 squared.
Yeah. W minus 2.5, and this is a tough one because they're not whole number and half answers, right? But take a look. 2.5 and 2.5 gives you the 5 in the middle. 2.5 times 2.5 is 6.25. And you can check that. It comes out to be 6.25. So yes, that would be written as W minus 2.5 quantity squared. Okay? The last one is the trickiest one of all. You would have to do AC, yes, to solve it, but if you can pick up on the pattern we've been looking at the whole time, what might you be able to say for this one?
2p plus 3 squared.
Yeah. Very good. How do you know that? Let's take a look. What's the square root of 4p squared?
2.
2p, right? Again, the square root of this number is just 2p. The square root of this number is just 3. That comes about from here. This was a square. This was a square. So to get these values, you just take their square roots. Okay, so that's a little bit of a way to save you some time. But again, if you use AC method, you'll get 2p plus 3, 2p plus 3. Okay? And you see if you FOIL this back out, you'll get the answer that we started with. Let's take a look at part A. Think about how you would do part A, please. How would you do part A here?
I want to rearrange this.
Good. Say again?
Rearrange.
Rearrange it. Very good. I agree. So part A, rearrange it as negative x squared plus 2x plus 8. Right, Ian?
Or you could just do x squared minus 2x minus 8, right?
Well, now we have to talk about that. That's what we're talking about now. You're right, and that's what we're going to do in a second. But what causes you to be able to do that? What can you factor out?
Negative
Negative, how much?
x. Not even 1.
Negative
1.
1. So I would write this x squared ever. Okay, so please write a little note if you didn't know that already. Whenever there's a negative in front of the x squared, start by factoring out the negative 1. Okay? Yeah, go.
X squared, or negative 1x squared, is it minus 4 and then x squared plus
You're saying squared.
2?
Why are you saying squared? Okay, just be careful. Okay? You're right. X plus 2 and x minus 4. That's correct. Very good. But again, please, it's just x. So, how many factors are there? It's kind of a weird question to think about. How many factors are there? 3. How come? What's the third factor? Yeah, the negative 1 is like a third factor there. Okay? So there's 3 factors in that problem.
Can we just multiply times negative 1 to get everything switched?
But this is not an equation. When it's an
It's
equation,
factor.
Dan, you're absolutely right. You're going to see that in the next section. We're solving equations then. If you had this, watch what I'm going to do. Imagine I went like this, and don't do this in your notes because it's not for this lesson. But if you set this equal to 0, and it's an equation
Oh,
now,
yeah.
then you can multiply by negative 1, because negative 1 times 0 is still 0, and negative 1 on this side would just switch all the signs like so. And then you can solve.
Yeah.
Absolutely. But if I'm just factoring, I need to show that negative 1 comes out of this factor.
Don't just get rid of it and throw it out.
Exactly. When you're solving equations, get rid of it. Just throw it out. Not a problem. Okay? When you're solving equations and everything. Any questions on the first one? Good? Second one. Second one. What two numbers multiply to 4 and add up to 3? 4 negative 1. So you would say it's u plus 4, u minus 1, like that? Agree? Disagree? Disagree. Yeah, 4 times negative 1 is negative 4, isn't it right? Okay, both negatives. Let's try that. What's negative 4 and negative 1 add up to? Oh, both positives. Sorry, both positives. Okay. What does 4 and 1 add up to? It doesn't make sense. Nothing's working, right? It's prime. Okay? It's prime. So here's how you do it. Think about it. What are the factors of 4? 1 and 4, negative 1 and negative 4, 2 and 2, negative 2 and negative 2. Do any of those add up to give you the middle term, which is 3? No. None of them do. Okay? This adds up to give you 5, negative 5, 4, and negative 4. None of those sum up to 3, so this one is prime. It is not factorable. Okay? Yeah, and that's the thing. You know what? And this is a common thing you'll see in the SAT. The answer will be no solution, or there's no whole number integer answer. A lot of students switch the 3 and the 4, and if you did that, you wrote it like this, watch. Now it works, right? U plus 3, u plus 1. That adds up to 4 and it multiplies to 3. A lot of people do that in their head. Don't be that person. Okay? Be careful.
That's wrong.
That's wrong, yeah, because they just switched the middle term in the last one. You can't just switch that.
Yeah, I understand.
But mentally, people do that. You know what else people do? Here's another one for you. Common mistake on this one. U squared plus 5x minus 6. Everybody thinks 3 and 2. 3 and 2. Oh yeah, 3 and 2 multiply to 6 and add up to 5. You tell me, try and figure out if 3 and 2 works there. It won't. It's 6 and 1.
How would it work if it's u and x?
Say again?
U and x, how would you?
Oh, sorry. Thanks, Phil. No, that's right. You're right. You're right. Absolutely, I agree. But again, 3 and 2 won't work here. The answer is 6 and 1. It's x plus 6, x minus 1. And so many people make this x minus 3x plus 2. Okay, you see that? Because these have to add up to give you the 5. 6 and a negative 1 adds up to 5. 6 times negative 1 gives you negative 6. Okay? Just be careful with these. That's your homework for tonight. Okay? Quick lesson for tonight.
Wait, didn't we already have 4 times over?
Yeah, but there's a few problems from 4 or 5 that I want you to work out. There's like 3 problems that do factoring with quadratics and 4 or 5. Okay? The class is over at 10:22, so we have like 4 minutes. Today was a quick lesson. And we have a short day, so I made sure that we were able to get through it. Any questions about stuff we've been doing? Any areas of concern that people are having trouble with? Mine was good. I think it was nice. Anybody do anything special? Sweet potatoes,
Pumpkin pie.
pumpkin pie. Carrot cake? Turkey. That's good. That's good too. It is Thanksgiving.
I like the sweet potato with the marshmallow.
All right, sweet potato and marshmallow. That's good. Gravy?